Hey, welcome to The Explainer. Today, we're going to crack the code on the real building blocks of all software. We're going to look at how programmers take what can be a really chaotic idea and turn it into clean, organized instructions. So, let's just dive right in.
I mean, seriously, think about it for a second. A huge online game has to manage, well, everything. From what your character looks like, to the quests you're on, to what happens every single time you press a button. With millions of players and constant updates, how does it all stay organized and not just, well, break?
And that right there is the core problem. See, without a good system, code can very quickly turn into what programmers call spaghetti code. It's just this giant, tangled mess where every piece is confusingly connected to every other piece. It's impossible to fix, and forget about adding new features. But don't worry, there are some really powerful tools to stop this from ever happening.
So, our very first tool for bringing some order to all this potential chaos is something called a procedure.
So what is it really? A procedure is basically just a chunk of code that you give a name to, and it does one specific job. The cool part is, you write the instructions once, give it a name, and then you can just call that name anytime you need that job done. It saves you from rewriting it over and over again.
For example, let's say you're making a game. You know you're going to need to show a welcome screen every single time it starts up. Well, instead of writing all that code out again and again, you can package it all up into a single procedure you call, say, show welcome screen. Just like that, it becomes a neat, organized, and totally reusable instruction.
Okay, so procedures are awesome for doing things. But what if you need your code to do something and then give you an answer back? Talk back to you. For that, we need our next tool, the function.
A function does everything a procedure does. It's a named block of code, it performs a task, but it has one superpower. It gives something back. After it's done with its job, it actually returns a result, a specific piece of information that the rest of your program can use.
Here's a perfect way to think about it. A procedure might just display the score on the screen, but a function will calculate it. You can send it the old score and the points the player just earned, and the function sends back the new total. The game then takes that number and uses it to decide what happens next, like maybe leveling up.
All right, let's put them side by side. On the left, you've got a procedure. It just does something, like showing a message. Simple. On the right, you have a function. It does something and it gives you a result back, like a calculated number. That is the one key difference. Procedure does, a function does, and returns. Okay, this all sounds pretty cool, but it brings up a new question, right? How do these procedures and functions actually get the information they need to work with in the first place? How does a function know a player's current health so it can calculate damage?
The answer is in what you can basically think of as the code's memory system. And that system is built on something called variables. They're like little containers for storing all the information that your code needs to remember and use later.
First up, we have global variables. Think of these as the game's long-term memory. A player's name, for instance, is needed all over the place, on the main screen, in menus, in chat boxes. By storing it in a global variable, any part of the code, any procedure or function, can look it up whenever it needs to.
On the flip side, you have local variables. These are like the program's short-term memory. A local variable is created just for one single task, inside one single procedure or function. As soon as that job is done, that variable and whatever information it was holding, poof, it just disappears. It's temporary storage for one job and one job only. So let's compare them one more time. Global variables are your long-term memory, accessible from anywhere. Local variables are your short-term memory, used for a brief moment for a specific task, and then they're gone. Using local variables is actually a great habit because it keeps your code clean and stops different parts of your program from accidentally messing with each other's data. Okay, we've covered a lot of ground here. So let's use a real-world example to see how all these pieces click together. Forget about games for just a minute, and let's think about something simple, like an ATM.
Okay, so here's the logic. First, you walk up and you type in your PIN. That PIN gets sent to a function. Let's call it check PIN. Now, this function does a task. It compares your PIN to the right one. Then, and here's the key, it returns a value.
If you were right, it returns your account balance. If you were wrong, it returns 0. Finally, a main procedure takes that return number and does something with it. It either displays your balance or it shows an error message. See that? The function provides the answer and the procedure acts on it.
We've just built up a really nice toolkit of programming's first principles. So let's do a super quick recap and put it all together on one handy slide.
This table pretty much sums up our entire toolkit. We've got procedures to organize our code and functions to get a value back. But wait, what's this parameters thing? Well, how do we get information into them in the first place? That's what parameters are for. They're like special doorways that let us pass data, like a player's name, into a procedure or function. And finally, you have our memory system, local variables for that short-term single-task memory, and global variables for the important stuff needed everywhere. That's your core toolkit.
All right, knowledge is one thing, but actually applying it is where the fun really begins. So we're going to end this explainer with a little challenge for you.
You now actually understand the basic logic that powers so much of the software you use every single day. So the real question is, are you ready to start thinking like a programmer and put these building blocks to work? So here is your challenge. In the next 15 minutes, just try to map out the logic for any simple system. A coffee machine, a website login, anything you want. You don't need to write code. Just use plain English to describe the steps. That's all pseudocode is. Your goal is to use at least one procedure, one function, and at least 2 parameters to pass some information around. With these tools, what problem will you solve first? Thanks for joining me on The Explainer.